Hi everyone. In this video, we will learn two types of sorting techniques, that is bubble sort and insertion sort. And also we will sort a list of items by using these two sorting algorithms and will implement in Python. So first, let's begin with bubble sort algorithm. So first of all, this type of sorting algorithm, the idea is to bubble up the shortest element to the beginning of the list. Okay, so how we will do it? We will do it by comparing and swapping. So first of all, take the first pair of elements in the list, the first element and second element. We have to compare both of them and we have to keep them in order if they are not in order. That means if we are sorting in ascending order, then the smaller one should come to the beginning and the bigger one will go to the second position. And if they are already in that position, then we don't have to swap it. Then the next thing you have to do, you have to compare the second element with the third element. And if they are not in order, then you have to just swap it. So like this, you have to go on doing till the last element of the list. And at the end of this first pass, then you'll find that the biggest element will be at the end of the list. That means it is at its proper position. So one element is sorted. Then the rest of the elements are still unsorted. Then you have to go to the next pass. That means you have to repeat the same process again on the unsorted part of the list. That means we'll compare the first element with the second. If the first one is bigger, then you have to swap them. Again, second with the third. If the second element is bigger, then it has to be swapped with the third element. Like this, you have to go on doing till n minus 1 elements. Why? Because the last element is already in its proper position. Okay, so like this, you have to continue till all the elements are sorted. Now let's see this how to do. Now just have a look on this list. There is a list having the items 5, 2, 4, 9 and 1. 5 elements are there in this list. So first what you have to do, you have to compare the first element with the second. That means 5 and 2, you can see the colored blocks are compared. Then they will be swapped. Why? Because 5 is the bigger one and we want to sort it in ascending order. So the smaller one has to come to the beginning. So it is swapped. Now your list becomes 2, 5, 4, 9, 1. Now we'll compare the second one with third one. That means 5 and 4 are compared. Since 4 is the smaller one, so it has to come to the beginning and 5 has to go back. Now your list becomes 2, 4, 5, 9, 1. Now 5 and 9 are compared with each other, and as you can see they are already in proper order. That means 5 is the smaller one is in the beginning and 9 is the next to it. So no need to swap. The next iteration 9 will be compared with 1 and they will be swapped like this. So we have already reached the end of the list. So your list becomes now 2, 4, 5, 1, 9. So this is the condition of the list after the first pass. That means the last element is in its proper position. The biggest element is at the end of the list. Now your unsorted part is like this 2, 4, 5 and 1. So we have to list short only this much 2, 4, 5, 1 excluding the last element of the list. So you can see in the second pass what you will do. 2 and 4 will be compared and no need to swap. Then 4 and 5 will be compared. No need to swap them. 5 and 1 has to be compared and they will be swapped. Okay, you have to stop there because no need to again do this operation with 9 because that is already sorted. Now your list becomes like this 2, 4, 1, 5, 9. So here you can see at the end of the second pass, last two elements are sorted. Now we'll go for doing the third pass in which the first three element has to be sorted. So 2 and 4 will be compared, no need to swap them. Then 4 and 1 has to be compared and it has to be swapped. And now your list becomes 2, 1, 4, 5, 9. So at the end of third pass, you can see your last three elements are sorted in its proper position. So in the next pass, what you have to do, you have to sort the unsorted part. That is first two elements 2 and 1 you have to compare. Yes, it has to be swapped. So 1 will come to the beginning and 2, 4, 5, 9. You can see the last four elements are in its proper position. So in the fourth pass, you can see the last four elements are sorted. and the first one element will be automatically in its proper position. So here you can see, since the length of the list is 5 and you got the sorted list after fourth pass. So this is the thing that you have to do. So you can just think of a for loop. You have to take two loops. The outer loop will iterate through these passes. Okay, and the inner loop will compare and swap the elements of the list. Now let's understand that better. You can see the list over here. Now we have to do sorting by doing the comparison and swapping of the elements of the list. So at the end of the first pass, you can see the last element will be sorted or will be at its proper position. So we'll take two loops. The outer loop will execute it as per the number of passes, and the inner loop will be executed to compare and swap the elements. So here you can see at the end of the first pass, that is the first iteration of the outer loop, you can see your the biggest element will be at its proper position, and for this it required four number of comparison and swappings. Four times it needed. That means we just took a variable I to represent the outer loop execution, and the variable j will iterate through the inner loops. You can see the elements 5 and 2 are compared and they swapped. That is the first iteration of the inner loop. And in the second iteration, the second and third elements will be compared and swapped. Like this, it will continue. So you can see here, you will require, so you can see at the end of the first pass, your list is looking like this. That means the highest element is at its proper position. So in the second pass, you will need to compare and swap for the first four elements. That means we'll exclude the last element. We don't need to compare and swap for the last element because it is already sorted. So you can see your second execution of the outer loop goes like this. Here the number of comparisons or swapping are made three number of times, you can see, and at the end of this second outer loop, you can see your list is looking like this, where the last two elements are already sorted. Then in the third execution or third iteration of the outer loop, you can see the inner loop executes two times, where the comparison and swapping are made for the first three elements. Then in the last pass, you can see your list is looking like this after the third iteration of the outer loop. And you can see after that it needed only one inner loop execution to sort the entire list. So here you can see your outer loop gets executed four number of times, that is n minus 1 number of times, where n is the length of the list. And within each outer loop, inner loop gets executed n minus 1 minus I number of times. Why? Because at the end of each outer loop execution, I number of elements are in its proper position or already sorted. So you don't need to compare and swap for the last I elements after the execution of each outer loop. So you can write your code like this: for I in range n minus 1, that means your outer loop gets executed n minus 1 number of times. For j in range n minus 1 minus I, that means your inner loop, that is comparison and swapping, has to be done n minus 1 minus I number of times. Why? Because at the execution of each outer loop, your I number of elements are already sorted. So you need to just compare and sort for n minus 1 minus I number of items. Now you have to just compare if L of j is greater than L of j plus 1. That means if the first element is greater than the second element. So you have to swap them. So L of j comma L of j plus 1 is equal to L of j plus 1 comma L of j. This is a statement by which the elements will be swapped. Okay. So at the end of this code, you will find your list is sorted. Now let's implement that in the program. Now your list is like this, having elements 5, 2, 4, 9 and 1. Now first of all, we will take the length of the list and we'll store it in a variable, let's say n. Okay, now your outer loop will execute for n minus 1 number of times. So you can write the code like this: for I in range n minus 1. Now for j in range n minus 1 minus I, as I discussed earlier, because we need to compare and swap for n minus 1 minus I number of elements. Okay, because at the end of each outer loop execution, I number of elements will be sorted. So you need to compare and swap for n minus 1 minus I number of elements. So your inner loop will execute that number of times. and within that, if L of j is greater than L of j plus 1, that means the first two elements will be compared. If the first one will be bigger than the second one, then they will be swapped. That means L of j will be L of j plus 1 and L of j plus 1 will be L of j. So this is the statement for swapping. So we can do the swapping. So like this, it will continue till n minus 1 minus I number of elements. Okay, like for example, in the first pass, you can see for I in range n minus 1, that means I value is 0 for first iteration, and j will have values from 0 to n minus 1 minus I, that is 5 minus 1, 4, 4 minus 0, 4. So j will have 4 values. J will range from 0 to 4, that is 0, 1, 2, and 3. So 4 number of times it will be done. That means L of j will be compared with L of j plus 1. That means the element at index number 0 will be compared with the element with index number 1. If it is bigger, then they will be swapped. Like this, it will continue. So at the end of the loops, you will find your list is sorted. So once you run the program, you can get the output is like this. The sorted list is 1, 2, 4, 5, and 9. Now let's discuss what is insertion sort algorithm. So this is a sorting technique in which the list is split into two parts, that is sorted part and unsorted part. And we have to take one values from the unsorted part and insert it in proper position of the sorted part. Okay, so in each iteration, one element has to be taken from the unsorted part and it has to be inserted into the sorted part, and that particular element is called the key element. Okay, so we will just consider that the first element of the list is already sorted. Okay, and the rest of the elements are unsorted. Clear? So we will continue with the second element of the list. Second element is considered as the key. Okay, now we have to insert that particular key in the sorted part of the list. That means it has to be compared with all the sorted elements which are present just before it. And where is the proper position of this particular element? In that particular position, this key element has to be inserted. Okay, this process will be continued till the end of the list. Now let's see. Now consider this list having values 5, 2, 4, 9, 1, 8, and 7. And we'll just consider the first element as to be the sorted part of the list, and the rest of the elements are present in the unsorted part of the list. And we will take the second element as the key. That means the first element of the unsorted part of the list as the key. Okay, now this key has to be inserted in its proper position. How? The key will be checked in the sorted part of the list, that means where it has to be inserted. So 2 will be compared with 5 and it will find that 5 is greater than 2. So 5 will move one position towards right, okay, making room for 2. And 2 will be compared to, there is no more element in the sorted part, so 2 will be placed or inserted before 5. Okay, so you can see here. So after this insertion, you can see your list is like this: 2, 5, 4, 9, 1, 8, and 7. Now your sorted part becomes like this: 2 and 5 are there in the sorted part of the list, and the rest of the elements are in the unsorted part. And we'll take the first element from the unsorted part as the key, that is 4. And 4 will be compared with the sorted part of the list. That means 4 will be compared with 5. So before comparing, what you have to do, you have to keep the value 4 in a variable, let's say key. Okay. So it will be compared with 5 and you'll find that 5 is greater than 4. So 5 will move one position towards right. Okay. Now 4 will be compared with 2 and you'll find that 2 is smaller than 4. So 4 will be placed just after 2. That means 4 will be inserted after 2. Now after that your list becomes like this. 2, 4, 5 is now in the sorted part of the list and 9, 1, 8, 7 in the unsorted part. Now 9 becomes the key. Now 9 will be compared with 5 and we'll find that 5 is smaller than 9. So 9 will be inserted just after 5. That means 9 is at its proper position. Now Your list becomes like this. Now 1 becomes the key and 1 will be placed in the sorted part of the list. How? 1 will be compared with 9 and 9 is greater, so 9 will move one position right. Now 1 will be compared with 5, 5 is bigger, so 5 will move one position right. So 1 is compared with now 4 is bigger, so 4 will move one position right. Now 1 will be compared with 2, 2 is again bigger, so 2 will move one position right and making room for 1, so 1 will be inserted before 2. Okay, so now your list becomes like this. So your sorted part of the list having values 1, 2, 4, 5 and 9. The unsorted part is having values 8 and 7. Among them 8 is the key now. So 8 has to be inserted in the sorted part of the list. So 8 will be compared with 9 and you'll find that 9 is greater. So 9 will move one position right. Now 8 will be compared with 5 and you'll find that 5 is smaller. So 8 will be inserted just after 5. Now your list becomes like this. Now the last element is unsorted, so you'll take key as 7. So 7 will be compared with 9 and you'll find that 9 is bigger, so 9 will move one position right. Then 7 will be compared with 8 and you'll find that 8 is also bigger, so 8 will move one position right. And 7 will be compared with 5 and 5 is smaller one, so 7 will be inserted there itself. Now your list becomes like this. It is now sorted completely. So how you will write the code for this? Can see. Take a variable j which will range from 1 to length of L. Okay, so here you can see the length of list is 7. There are 7 elements. So j will have values 1, 2, 3, 4, 5 and 6. Okay, and we will take L of j as key. That means the element which is at index number 1. That is your key. Okay, now I becomes j minus 1 or I becomes 0 here. Now while I is greater than or equal to 0 and L of I is greater than key, that means key will be compared with the sorted part of the list. That means all its previous elements. Okay, because the previous elements are sorted. That means the elements which is starting from key till the end of the list, those are unsorted, and which are just present before the key element, those are all sorted. So key will be compared with its previous element. Okay, in this case. Okay, so L of I plus 1 is equal to L of I. That means if the value is bigger than key, that means it has to shift one position towards right. So that is done through this code. L of I plus 1 is equal to L of I. Okay, now I becomes I minus 1. Okay, that means what will happen? Just consider the second instance of the list where 4 is the key. Just consider focus on that one. So here in this case, your j value is 2 because in this case for loop will be executing for the second time. So key value will be L of j, that is 4. Okay, and I value is equal to j minus 1, that is 2 minus 1, that is 1. Okay, so I will be starting from 1 to 0. 1, I will be having values 1 and 0 now. Okay, so L of I plus 1 is equal to L of I. So it will find that 5 is greater than 4. So 5 will move one position towards right. Okay, now your I becomes I minus 1. That means it will check the previous element. That means I becomes 0 now. It will check with the previous element. So key will be compared with 2 now. 4 will be compared with 2. And it will find that it is greater than 2. So your for while loop will stop executing over there. Now L of I plus 1 is equal to key. I was 0. So L of 0 plus 1, that is 1. So L of 1 will become 4. Okay, that is how your insertion will take place. So you can see your list is like this. L is having values 5, 2, 4, 9, 1, 8, 7. And for j in range 1 to length of L, key is equal to L of j. That means initially key is having value 2 and I is equal to j minus 1, that is 0. So while I greater than 0 and L of I greater than key. Okay, that means whenever the values or the elements of the list are not less than the key value, then the elements will be shift one position towards right. That means L of I plus 1 is equal to L of I to make room for the key. I is equal to I minus 1. This loop will continue until L of I becomes less than key. That means whenever it will find an element which is less than key, it will stop there. Now L of I plus 1 will be key. That means key has to be inserted in its proper position. Now the sorted list is like this. You can see the sorted list is 1, 2, 4, 5, 7, 8 and 9. So here ends this explanation of bubble sort and insertion sort. Here we have discussed the two types of sorting techniques and how to sort them by using any of these two algorithms. And we have also implemented these two algorithms using Python program. And if there is any doubt, you can put it in comment section. Stay tuned and do subscribe. Thank you.